Well, we're moving on to the third lecture of today. It gives me great pleasure to introduce John Cleary. Now, John is a lecturer in linguistics at the Heriot-Watt University in Edinburgh. And he is also the project administrator of several surname studies, the Kemp surname study, the Cummings surname study, and the Cleary surname study. And John has done some incredible work with these surname studies and has used SNP testing as well as STR testing in both of these studies to elucidate the origins and the evolution of these surnames. So here to talk to us about making the most out of your Y-DNA test, please give a warm welcome to John Cleary.
Thank you, Maurice, and thank you everybody for coming to hear me today. When I was standing at the back earlier, the sound level was quite low for the back rows. Can you all hear me clearly at the back? You can, thank you very much. If you can, everybody else can, I think. So, Y-DNA used to be the way in which most people would begin their first genetic genealogy projects. In the last several years, autosomal DNA testing, as you all probably are aware, has become huge. But Y-DNA still plays an important role in certain kinds of projects, particularly if your genealogical interests are a bit older, going back into the 18th century and so on. So I'm going to talk about beginning approaches to Y-DNA testing. And I hope I'm not going to pitch it too low, but I was asked to give a first level talk about Y-DNA today. So first of all, can I ask you, how many of you have taken a Y-DNA test for you or a close relative? Most of you. So obviously you're all experts. I'm going to be pitching my beginner's level talk to people who know everything already. Anyway, let's see how we go. So these are topics I'm going to look at today. Look at the kinds of markers, the kinds of tests you can do, and who provides them. Then what can we do with our results? What can we do with matches? Because Y-DNA matching is a little different to matching in an autosomal test. We'll look at a couple of tools for analysing your Y tests. We'll look at projects, how you can create them. I've got a couple of example case studies. So I hope even if you have taken Y tests and you are familiar with this area of DNA testing, there'll be something in this for you. Starting from the beginning then, as you are probably all very well aware, there are 23 pairs of chromosomes in the genome. And the Y is this rather unusual little stubby chap right at the end here, this stunted chromosome. Which is only found in men, and of course is what determines you to be a man. And so it's one of the two sex chromosomes, and of course what marks it out from all the others is it does not recombine. It does not shuffle down the generations every time a new child is created. Therefore, if you're a man, your Y-DNA is probably pretty well the same as your father's, and his father's, and his father's, with occasional differences appearing down the generations. So, with Y-DNA, the actual sequence of the DNA matters. We're comparing that with other people, and we're trying to work out how far back in time that male line ancestor may be. A little different to what we do with autosomal DNA. And just again, as this is a beginner's test, I will be talking about things like A, G, C, and T. So here's a quick diagram of the DNA spiral. And of course, the four bases, adenine, thymine, guanine, and cytosine, are usually referred to as A, T, G, and C. And these are the chemical units that can mutate on a chromosome. So Y-DNA looks partly at how these four bases may mutate one to another down generations. So why do Y testing then? You're probably familiar with the three tests. In addition to the very popular autosomal tests, there are the Y-DNA tests, specifically looking at the Y chromosome in men. There are also mitochondrial DNA tests, which look at the mitochondrial DNA that all of us have, but we only inherit it from our mothers. and only mothers can pass it on to their children. So we have 3 forms of DNA giving us 3 different kinds of descent line. The autosomal DNA at the bottom here can look at all of our descent lines, but it's limited. There's a time horizon that will not take us very easily back beyond around about the year 1800. Usually 5 or 6 generations are within the range that autosomal DNA can reach. So if your interests are in older genealogy, you will need to look at some stage at the other 2 forms of DNA test. And these have the advantage of going back indefinitely over generations. So the mitochondrial DNA and the Y DNA, because they're passed on largely the same, will always be the same all the way down those lines, apart from the occasional mutation they pick up. And therefore we can look into deep history, potentially, if we want to, because right back to the beginning of the human race, we can see a very limited number of changes in these 2 so-called uniparental lines. So what it offers for the genealogist is if you want to research your 17th century ancestry using DNA, then these 2 are the main possibilities. Just a note, of course, they only go down those 2 lines. They only look at the all-male father line or the all-male female line. However, they can reach back much further in time than autosomal DNA. That's why they are now a more specialized form of DNA, but still a very, very useful one. So there are 2 kinds of markers. Many of you are probably familiar with these already. Morris mentioned them just now, but I'm going to just very quickly summarize the kinds of things we're looking at in doing a Y-DNA test. Just to note, these markers are found all across the genome, but on a Y-DNA test, this particular kind called STR becomes very important. These are short tandem repeats, or short strings of A's, C's, G's and T's, which are repeated at a particular point on the chromosome, like a kind of DNA stutter. So here we have an example of a string CTA that gets stuck in a way and gets repeated several times, and we've got 3 sample results from 3 hypothetical men here. One has got 5 repeats in this CTA at this particular place. One has got 6 repeats, and one has 7 repeats. So already we've got a means of distinguishing between these 3 people. So this is junk DNA, by the way. It doesn't actually use, in most cases, it doesn't actually have any effect on who we are, how we become, on our health. So it's DNA which we can look at. It's not going to reveal health information, but we can use it to find out these generational differences. So what we do then in this kind of test is we count the number of times this chunk repeats, and therefore the results table, I have an example here, simply lists how many repeats of different markers there are at particular locations. So here we have an example. We've got 3 men called Cummings and 1 man called Brown, but it has a Cummings male ancestor, and they have very, very similar DNA results. The first 2 columns are exactly the same. 13, 24, they all have the same number of repeats of that STR at those locations. But on the next 2 columns, you'll see a difference. Mr. Cummings number 1 has only 14 repeats in the 3rd column, the others have 15. Mr. Cummings number 1 also has 11 repeats in the next column, the others all have 10. So these are very small. It's only 1 step difference, but clearly at some stage the ancestor, probably a recent ancestor of Mr. Cummings 1, has gained extra repeats at 1 marker. No, actually he's lost them, hasn't he? Yes, he has gained 1 at 1 marker and lost 1 repeat at another marker. And that's what happens. We're looking for these small differences that suggest that, okay, the DNA is largely the same, but these small differences imply that there may be a divergence in very recent time. If you find people have got lots of differences, then they will not be related. That means that their divergence is much further back in time. They're not genealogically related. So STRs then are actually very, very good at eliminating relationships. If you test two people and they have lots of differences, you know they're not related in the male line. If they have the same DNA, they may be related. It gets a bit more complicated. The second kind of marker is usually known in the trade as a SNP. The technical term is a single nucleotide polymorphism. I'll just unpack that. You can forget it, by the way. But polymorphism means change, and nucleotide is those points, those A's, G's, C's, and T's along the chromosome. They are the nucleotides. So what this simply means is a single mutation at a single point in the Y chromosome. And here we have an example. The first man has a T, the arrow's pointing at it. Let's pick that out. And the other two men both have an A at this point. So either the first one or the second two have an ancestor who mutated from the original shared pattern. And of course, we don't know when that mutation was. It could be in recent history, it could be in deep time. And you do more testing to try and work out where that SNP mutation may have happened, and could it therefore be a marker of a common ancestor that's genealogically useful. So SNPs then are point mutations. They tend to be stable, at least in terms of how long human history is. These SNPs don't change very often. Once they change, they will probably stay the same for us all the time that we are concerned with. Whereas the STRs, they're like a bubbling cauldron. They're upping and downing, chopping and changing all the time. So SNPs are stable, STRs a bit less stable. They have different properties. Used together, they can be very powerful in building the male line descent tree. Now, I'm not going to talk about SNPs today. Graham Hulton from Strathclyde University will give a talk tomorrow, and he will talk about SNPs. Today I'm going to focus on what we can do with the other markers, the STRs. So if you want to get your Y tested, which company can you go to? There's a very small select number of companies which specialize in Y testing. And here they are. But for most of you, if you're starting off with Y testing, you will be almost certainly dealing with family tree DNA. Family tree DNA run the 37, 67, 111 marker panels you may have heard of. They also do a Y sequencing test called the Big Y. That's quite an expensive test and a very advanced one. You may come to do that eventually. It is quite useful for many genealogical questions, but if you're beginning, you wouldn't look at that. You'd look at the marker panels, which are cheaper and therefore lead you into STR testing. The other two companies, YSeq and Full Genomes Corp, I mention them here to be fair and open to all testing companies, but they, for the most part, they don't do STR testing. YSeq do, but there's very specialized reasons. Therefore, if you're beginning with Y testing, family tree DNA is almost certainly going to be your first port of call. Now, family tree DNA offers something that's very important for Y testing. They have a dynamic matching database. So when you take your results, it'll be compared all the way across that database to find who else you may match against. And there's no point doing a Y test if you're not going to be able to make those kinds of comparisons. So family tree DNA largely corner this very specialized market, but again, it's a very important part of what they do. So who can give a Y test sample? I want to just mention this very briefly. Many people think it's just for men. No, certainly not. Of course, the tester has to be a man, because only men have Y chromosomes. But you can be the donor of a sample for another researcher in your family, male or female, who is researching that particular line. So if you're a woman and you have a question that you think needs to be answered about, say, your father's line, you can ask a brother, your father himself, cousin, uncle, somebody who's on that line to give you a test. Run the kit. So therefore, Y DNA testing is just as important to women genealogists as it is to men. And in fact, I would estimate that probably the majority, I think, of the people who run kits in my project are women. Certainly a very, very large proportion are women. So, let's look at matching then, results matching and what we can do with them. So, when you get your results, it will look like this. Yes, this is actually mine. Fascinating. Can you learn lots about me? It's just numbers, of course, isn't it? And, of course, we need to know how to read these numbers, and then we need to know what to do with these numbers. So I'll point a few things out in the table. First of all, these scary-looking numbers at the top, DYS, blah-de-blah-de-blah, these are the labels for the various markers on the Y chromosome. DYS means DNA Y sequence. And then they're all numbered. Most of these markers, not all, most of them have a label like this. And of course, experienced administrators and genealogists who use these tests can reel off their marker values of this. Like, I'm DYS 392 equals 11, you know. Here it is. How do I know that? Well, actually, because that's very rare. That's my rare mutation. And I'm picking up the number here. I have 11 repeats at this particular location. And that is unusual, because most people in my broader descent group would have 13. If you're an R1b male, as I am, you should have 13 repeats in this rather stable marker. I have 11. So it's kind of the opposite of spinal tap here. Mine goes to 11. And this means nothing at all, except then if I find other people who are R1b and 11 as well, then we may have some kind of relationship. And I'll come to this a little bit later. One more thing here. There are quite a few markers that have multiple numbers, just to point these out. We call these multi-copy markers. And basically over time, sections of your chromosome are copied all over the chromosome. Sometimes they include STR markers, and therefore the same marker may exist in more than one place. And the test will read them in all their places. The one I'm highlighting here has got 4 values. That means it occurs 4 times. The test will read all 4 of those, and they mutate at different rates, so there can be different numbers. These are quite useful because they're quite fast mutating, which means if you're looking for genealogical mutations within the last 400 or 500 years, there's a good chance you may find them on these fast marking mutations. Other markers that family tree DNA use are very slow, and that's to stabilize the range of marker results. So you have many which will always be the same, or almost always be the same into deep time. And this means using the 2, you begin to work out estimates of when the shared ancestor might be between 2 people. We'll come to that as well. So I've used the term genealogical time. And of course, my results on my own mean nothing. They must match with somebody to be useful to either me and that other person. So the match, if you're using this for genealogy, needs to be in that genealogical time, which we can also call the surname era. And the surname era is very roughly taken, in England at least, to be about 700 years ago. In Wales, a bit more recently. In Scotland, maybe slightly more recently. In Ireland, of course, much older, but that's a different story. So 700 years then is what we generally call genealogical time. That's the time when most English people would be carrying surnames. And this, if we take a generation as being about 30 years, plus or minus a year or 2, then this is about 24 generations back. Now, that's probably a bit too far for most of your genealogy. Can I ask you, do any of you have a descent line that goes back to 1300? What's your surname, sir? Thank you. Either Angas or Angus, that's a Scottish name, I guess. So you must have a Scottish clan lineage that you've tapped into. Yeah, very useful. And actually, one of the things we're interested in researching is trying to connect very deep genealogies to these Y chromosome results. So some of my colleagues at Strathclyde University are collecting very deep, long genealogies back to the 15th century or earlier. So if you have one, do get in touch. We'd like to know about that. Most of us, though, are probably realistically looking at more like the 17th century. If you're English, you've got good chances. If you're Irish, 19th usually, Welsh about the same, so we can't go back that far. But certainly public records became much more common in the 17th century, and that's more or less really where many of these lines can begin to look back to. So let's look at a match list then. This is from a Kemp person who's in one of my projects, Surname Kemp. And I've shown the surnames down the names of the matching list, but I've redacted the first names to keep the privacy of the individuals who've tested here. And this is a match list of my Kemp relative at 67 markers. And this person, you can see, has 4 matches at this level, and gratifyingly, all of them are called Kemp. So this suggests that there is a clear surname cluster here. No one else is being brought in at this stage, and therefore this might represent a common surname descent line. Let's look at this a little bit more closely then. What constitutes a match, first of all? Well, family tree DNA have a system for identifying who your match is. And to put it very, very crudely, it's if you share 90% of the markers the same and have differences between them of no more than 10%. So if you test 37 markers, then no more than 4 differences. If you test 67, no more than 7. If you test 111, no more than 10. Now, it's more complicated than just 10%. There's more going into the calculation, but it's a very good rule of thumb there to work out how closely. Also, if you only share 7 out of 67, technically you are matching that person, but it's a very distant match, and it might actually not be genealogically useful. Anyway, that's a starting point. So here are the genetic distances. That's the number of markers difference between these Kemp gentlemen and the one that they're being matched against. And you see they're actually quite high. 5, a couple of 6s, 1 7 against 67 markers. This group actually does seem to show a bit of divergence from each other. Although for various reasons I still believe the common ancestor is probably somebody who left Scotland and moved to Northern Ireland, well, Northern Ireland to Ulster in the 1650s, and therefore looking about 3 or so hundred years back in time. Could be a bit early, of course. So genetic distance, then, is a very important measure. It actually measures the degree of difference between you and your matches. And if it's less than 10%, that's a sign you should start getting very interested in that person. Does it matter if you have a close match with different surnames? Yes, because a match is a match, and surnames can change for all kinds of reasons. So the surname can be an indicator, but especially if you're looking at people who have a descent from colonial America, surnames often change very rapidly. And they may, of course, be American cousins of yours if you take these tests. However, there can be false positives, so don't assume that a match is definitely somebody related to you. There are reasons why false positives are possible, but it helps a lot when the surnames are the same. And also if you tested at least 67 markers. The more you test, the more robust the measure can become. So the next thing to look at then is what we call the haplogroup. And again, Graham will say more about this tomorrow, I think. But very, very briefly, we do look at the general descent group that people fit into. And these are tested by SNPs. So the SNPs I mentioned earlier can identify very deep ancestors, usually in ancient or prehistoric times, and they form part of your haplogroup. Out of that later, in medieval times, surname lineages will start to emerge. Haplogroups are useful because they let us see what the expected STR values could be. So we can identify special rare markers like mine that can lead us towards particular kinds of relationship. These people here, don't worry about the number, the M1417 and so on. It's just telling us that these people are members of the R1A haplogroup. And once we know that, we can look at the expected STRs in that haplogroup to see whether any of these people have unusual ones that might be indicative of a particular recent descent group. There's a very nifty calculator called NevGen I recommend to everybody if you want to find out your haplogroup. Family tree DNA give you a very rough estimate. NevGen will give you a more recent estimate. You can copy your results, drop it into their website, click, and it will then compute across its database and make a prediction. This is mine, and it's telling me as 100% certainty that I belong to this group they call Y9096. Well, I know there's 100% certainty because they know that from my haplogroup. I was the first person to be identified in that group, and there's a few more since then, most in Ireland, some from Norway, interestingly, and these have presumably been collected by NevGen. They've collected all the haplotypes, not the personal identifying information, and they can recognize known haplogroups if you're in one. And that can be very helpful. Of course, you may not be in one, so here's an example from one of my Cummings projects. This person is not in a group that's done any recent SNP testing, and so NevGen is saying 91% it's in an unknown subclade. That means haplogroup. Therefore, it doesn't have anything in its database that looks like this person. So that may also be the case. And the next thing to look at on the results chart, and I think perhaps the most important, that's often neglected by people, is the most distant known ancestor. So these 4 Kemp gentlemen have all inputted the earliest male line ancestor that they know of. This will not be the common ancestor. The common ancestor is before all of these. This is simply where they can go with genealogy before it runs out. And gratifyingly, these ancestors all come from County Cavan in Ulster. That's where the Kemps are found. In fact, the surname is only found in certain pockets in Ireland, much more common in England and Scotland. In Ireland, you find it only in Cavan and Kemp. And I set out some years ago to find out if all of the Kemps of Cavan were related to each other. I believe they are. I was told that, oh, no, we're not. We're different families. So I trawled around the county. I tested my uncles and found other relatives, some in America. A professional genealogist called Tom Kemp took part in the sample. He's one of us. I went to a farm, tested a farmer who first thing he said was, John, some whiskey, some cake, some coffee. And by the way, you're supposed to have a clean mouth when you take these samples, but the whiskey, the cake, the coffee all got in there, but didn't actually do any harm to the samples because it was tested very nicely and got the results we wanted. So we had some interesting research, and I think we demonstrated that yes, there was a relationship and a common Kemp ancestor, either in Ireland or Scotland, from whom all of these men do descend. We just don't know who he is because he lived before the records that can put a name onto him. We're still trying, but I think we've accepted we'll never know the name of that man, but we may be able to hone in on exactly when he lived more precisely. So these MDKAs are very important because they help your project administrators, your matchers, to know where your ancestor came from, what the ancestral name is, and whether there's any similarity to their own. Many people leave these cells blank. I encourage you, please, fill them in if you're doing Y testing for yourselves or other relatives. So, there are ways of estimating TMRCA. I'm going to go a little bit quickly to try and move on to some case studies. But I've got 2 tools here which can be used to try and work out when ancestry may be shared. TMRCA means the time to the most recent common ancestor between a group of testers. Family tree DNA have a nice 2-way comparison tool that lets you work out the probability that 2 people may have a common ancestor within a certain number of generations. And I've run this for 24 generations, that's the surname era, against all my Kemps, and I'm getting numbers around about over 90% probability that the most recent common ancestor lived since about 1300 or 24 generations ago. Now, actually, 90% is not great, so I am beginning to revise my confidence that the common ancestor really did live in the 1600s. It might actually be a bit older, so we're working on this. That's on Family Tree DNA's database, a really good tool, one of my favorites, and I think anybody who uses, is doing a set of Y-DNA tests should use this, is the Dean-McGee utility, which can estimate common ancestors, or estimate the time to a common ancestor, and also give you some other useful information. If you look at the slides of this later on YouTube, you'll have a reference here of how to set the Dean-McGee site, but some very important markers to set. I'm going to move away. Pointer.
Thank you very much, Maurice. You can still hear me through this. Very important. This is the Dean-McGee utility. It looks a bit scary. Don't worry. It simply lets you drop in a set of Y-DNA results from several people all at once, and then it'll tell you an estimate for the most recent common ancestor. You need to watch out for a couple of things. Look for the right mutation rate. I always recommend using the family tree DNA mutation rate set here. And look for the probability, and I strongly recommend you look for probability at a 95% level. A lot of people in the past, me too, I'm guilty of this, used to use 50% and say, ooh, we're all related, how nice. But actually, that only gives you a 50-50 answer. Today, I think the research we're doing from all Y mutations suggests we need the 95% level. And you can decide whether you want output in years or generations. And then you simply copy and paste
a set of results, and you'll get something like this. It'll arrange them for you into clusters. So here I've got all my Kemps and some other surnames that seem to be closely related, Jacobs and Cummings, and the green squares are showing clear descent clusters from a common ancestor. In the middle, all those Jacobs, we know when the common ancestor lived. He was born in about 1630 or 40. And so that's, in a sense, looking a bit more recent, I think, those 2s, 3s and 1s, than my Kemps, still having a green square there, but that actually is possibly a slightly older common ancestor. And we have a sneaking suspicion that Mr. Jacobs, who went to America, was actually really a Mr. Kemp on the run, who was getting away from something and changed his name as he went. Research is ongoing there. So I'm going to move on quickly from this to try and get a couple of case studies in. So first of all, I'm going to tell you about my fishing trip in 2012. I went fishing in Y-DNA a long time ago. The fishing trip is one Y-DNA testing strategy you can use. I wouldn't always advise it, but you might just want to know, who do you match? You may have no real question. I was very skeptical about DNA testing in those days, and someone persuaded me to do a Y test. I thought, oh, all right. Not expecting to find very much, and I'll show you what I found in a moment. But, of course, if you do a fishing trip, you never know what you might find. So be careful. There could be skeletons or sharks lurking in that closet. It's better if you have a hypothesis. If you want to test something, be a little bit scientific about this. Maybe you have a theory that you and somebody else with a similar surname are related. So test both and see if you're sharing similar looking DNA. Maybe even you share a striking resemblance to somebody and you'd like to explore this a little further. But this essentially is testing two people looking for a match. A third way to approach this, I was doing this with my Kemps, is a family reconstruction project. So I began with a fishing trip, I moved into a much bigger project, trying to find out not only are two people related, but actually is a whole group of people with the same surname and the same geographical region related? And could we also determine the branches of that descent? Which ones are more closely related? Which ones more distantly related? So it became a family reconstruction project of the Kemps from Cavan. So my fishing trip then, 2012, I tested 67, upgraded to 111, and thought, I'll get loads of matches. not one. No matches at all. At 67 marker, also no matches. At 37 markers, no matches. In fact, I had to drill down to 25 markers before I found any match at all. Now, that's not actually a good practice because I've done a bigger test, so I shouldn't be cherry-picking the 25. All the same, the man who matched me was kind of close to being a match all the way along, and he had that rare DNA marker. In fact, I knew nothing about it then. He told me I had it. I thought, oh my God, I'm a mutant. Now what? Unfortunately, this match was not called Cleary. That surname was Gorman. And this is 2012, autosomal DNA testing hasn't really taken off, and I'm finding myself wondering, is he a Cleary? Am I a Gorman? He said, well, actually, John, you're a Gorman. It's obvious. To him, it was an open-shut case. And for a while, I began to believe that maybe I descended from we call NPE, or not the parent expected line. Particularly when I discovered a Gorman with a big farm, farming next to my Cleary ancestors' tiny farm in Tipperary. And I thought, it's a bit too close for comfort. Actually, I'm sure now it's not the case. But at the time, I was thinking maybe there's something here to discover. Hence my shark in my fishing trip. So we did a bit more investigation, and I had no Cleary matches, so I went to look for some. And there's no point testing my father, my cousin, my uncles. I know who they are. I have no reason to doubt they are who they are. So I approached, or a cousin of mine approached me, a distant cousin, descending from Clearys in Tipperary. We believe them to be cousins. We just don't know how. There's a brick wall through which we cannot get to link his Cleary family and mine. So we found a male in that family, and we tested him for 37 markers. And we also did some genealogy research. That's me. We're able to get a long way back because my family has a grave in a ruined chapel in rural Tipperary, guarded by a fearsome bull. My uncle and I braved that one day. We're saying, you go first. No, you go first. And we're deciding if we're chased by the bull, was it going to be every man for himself, or would we try and help each other? In the end, the bull was more interested in the grass than us two. But my cousin can't go back beyond 1825. So that's his MDKA. And there's a birth certificate for this man. It shows, sorry, a marriage certificate rather, which shows that in 1874, when he married, probably for the second time, he was 50 years old, or at least that's what he's telling her. And we tried to pin him onto a couple of possibilities. One younger, which we've ruled out. One a bit older, we thought could be a possibility from my family tree. We actually have ruled that one out as well now, so we still don't know. But we began to try and test this with the Cleary. See, does he match me closely enough to be a close relative? And here's his results. There are some differences. I've highlighted these. There are actually 4 markers that are different between me and him. And one of them with this horrible 3-step match here. So it's not just 4 markers. It's actually a genetic distance of 6 out of 37 between me and him. So, members of the audience, are we matches? Are I and that other Cleary related to each other on this data? Who says yes, we are? Nobody. Oh, Morris does. Thank you, Morris. Who says no, we're not? A little hand twitching down here. Not sure, yeah. I asked this question in Ireland, in Dublin, a couple of years ago. All the hands went, no, you're not. No, you're not. Yeah. But actually, we are. I'm sure we are. And I can't explain that big gap. Maybe that's a big one-step mutation. I've mentioned 2 kinds of counting methods for genetic distance here. If we just count the steps, then there are 3 here, plus the other 3 makes 6. But some people will use what's called the infinite alleles model, and they only count the number of markers that are distant, and 4 out of 37 is just close enough. So we have actually done further testing, by the way. I'm sure we are related. We still don't know how closely, however, because we don't match on autosomal DNA testing. But he shares that rare marker with me. And there's a very, very useful resource produced by a veteran genealogist called Leo Little, who's now died, who left this as his legacy. And it's a collection of statistics about rare markers and common markers. So I'm in R1b here, and the pink one down the bottom. And people in R1b, as I mentioned earlier, 86% of them have 13 at this particular marker location. I have 11, and only 0% of R1b people have that value. So it is very, very rare. And it's not completely limited to my family, but it seems to be largely limited to my Cleary and the Gormans as well. Thank you. So that signature marker tells me we probably are related. We've done Y sequencing since, and yes, we are, but we still don't know who the common ancestor is. Now, if you're testing, you're more likely to get a matched list rather like this, which shows several other surnames. And the question is, should you take account of those other surnames? Maybe you should, because a match is a match, but there are plenty of reasons why a match with a different surname may actually not be matched to you. One is the so-called NPE, the non-paternal event, often referred to by genealogists as the not the parent expected. So in other words, yes, you're a match, but there's been a switch of surnames somewhere in the line. There's convergence. Different haplotypes, different result sets can mutate and move towards each other. So a much more distant relationship can appear to be much closer. But there are also surname clusters. If you go back before the use of surnames, there may be a closer relationship in, say, the period roughly 800 AD to 1300, in which there is a common ancestor whose descendants then adopt different surnames. And so the Kemps I've mentioned already, Jacobs and Cummings, all appear to be in this surname cluster that we are investigating to see how closely related they may be. So almost finished then. I'm going to, very, very quickly, I'll show you how I approach the Kemp project in Cavan. This complex diagram here is actually all the lines. Before testing people, I researched the genealogy as far back as I could go. Because genealogy, when linked together with DNA testing, is the most powerful way you can approach it. So all of these red boxes indicate lines where I managed to find a DNA test. All the blue ones, I'm still looking. Some of them I'll never find because all the male lines have probably died out. And just to exaggerate here, you can see I'm linking some of these lines hypothetically because I think they're connected, but I don't know. I'm hoping DNA might be able to give me evidence there. And some lines, as you see here, do die out. So I have some 18th century records allowing me to reconstruct this line, but I can't find any proof of descent. And so these probably are the oldest Kemps in Cavan, but I can't so far find people who directly descend from that with any certainty. And then down the bottom, I have various testers who donated samples to me. And what I found eventually was I could make a more consolidated tree, linking up some of these branches, rearranging some of them, so I now think there are 3 broad branches I can connect with some confidence, and my next task is to try and find the evidence to bring those 3 broad branches together, probably converging on that older line I mentioned. So, I'm not sure if I have time for my third case, but say very, very quickly, I worked with an adoptee recently, and the autosomal DNA testing he was doing didn't actually lead into a clear answer, but he also took a Y DNA test that pointed very strongly towards a surname, which wasn't Little, but I'm calling it Little. He matched against people with a surname that could be Little, definitely a Scots or Northern Irish surname. And you won't see these trees very quickly, but eventually we found, after doing some paper research, that a relative of his third cousin, whom he matched in the autosomal test, had married as a young woman to a man called Little. And this then produced a son who was the father of this adoptee. And so in the end, the Y test became the crucial piece of evidence that allowed us to crack that case. The autosomal testing probably would have got us there eventually, but it wasn't getting the results. But Y DNA short-circuited the route and got us to the answer very quickly. So even if your interest is mainly autosomal, you can actually get very important and useful results by targeting people for a Y test. So I'm going to jump over some slides and take you down to the plug section. How do we enlarge this again? This is it. Oh, yeah, that's it. Thank you, Maurice. Yeah, here we go. So there are some excellent books about Y DNA testing. Debbie Kennett's Surname's Handbook is the best book you can read about how to build a surname project and build Y testing into it. Turi King, David Hay and George Redmond's excellent book on surnames looks at DNA testing, how it can also tell us about surname history. And there's the DNA into Your Genealogy, written by a man who's sitting very close to us at the front here, which again is a very useful summary of how to go about a Y DNA testing project. And there's a new one, will be appearing shortly. Edited by Graham Holton, who's going to speak tomorrow in the same slot about Y SNP testing, and I've also contributed to this book, and a couple of links here. So I'd like to thank you all for being a very patient audience and listening. I hope those of you who've done Y testing have found something useful here, and those who haven't will see the uses of it and will be interested to try and do it someday. Thank you very much. I'd like to ask if there are any questions from the audience.
Great. Thanks very much, John. Fine. We have a question down here.
You never mentioned living DNA.
I beg your pardon?
You never mentioned living DNA.
Thank you. Living DNA have Y SNPs on their testing chip. Actually, so does 23andMe, but they only give you a fairly old haplogroup reading. It's not really useful for genealogy, in my view. Yeah.
Any other questions? Very interesting in the second case study where you actually are linking the family trees, the various pedigrees, to the actual DNA. Where do you think? I mean, that is the way forward with a lot of surname studies. What do you think is going to be the next big step in that regard? Is it going to be on the genealogical side? Is it going to be on the DNA side?
I think there's always a sense in which it could be on both. Because on the genealogical side, I think that often DNA testers don't necessarily realize you have to go back and do more intensive genealogy. So the DNA testing needs to be the lead that takes you to where you need to look next. And I have actually made discoveries in documentary research that I wouldn't have even looked for had it not been for the testing results. As for the DNA side, technology is enhancing all the time, and I think whole genome sequencing is going to be big. There are already companies selling tests that will read your whole entire genome sequence. They are becoming cheaper and more affordable, which offers the prospect of getting everything read in a single go. And then, of course, the challenge at the moment is how do you then crunch all that huge amounts of data. So at the moment, there are very few tools to exploit whole genome sequencing, but it does, I think, offer possibilities for integrating different forms of DNA tests, and not talking about the 3 tests anymore, but simply saying, I'll test my DNA, and then I need tools to extract the information from it to answer my questions.
And of course, the whole genome sequencing is not just going to test the Y chromosome, but it's going to test all of the other chromosomes as well. So we'll get much more fine, detailed, granular autosomal DNA results. Do you think that will be then integrated into the Y DNA surname projects, like your Kemp project, and that will actually help us connect some of those lines that currently are just hypothetically connected to each other genealogically?
Yes, I think so. I think, of course, it may not help me because I'm trying to connect lines that converge at a point in the 17th century or earlier. So I don't I can't see autosomal testing being able to resolve those kinds of questions. But I think that there are more surname projects who are trying to find ways to use autosomal testing to try and build up lines more recently. I'm working with a lineage society in the USA, a Cummings lineage society, and they've tested 50 people with Y DNA with a great descent tree, but we have a lot of people coming along who have the right Y signature, but don't know where they join on that tree. And so there may be more recent common ancestors identifiable through autosomal testing that allow us to say, right, clearly, this is the branch of the tree you belong on. So I think we do need to integrate, yes.
Any other questions at all? We have a question down here. Let me bring you the microphone. There we go.
Well, first, thanks. Yeah, okay. Yes, thanks for a extremely illuminating talk. My results are the 37 markers. Should I upgrade?
I would never say to somebody purely on the number of markers you have. I think you have to look at those markers and see what you can already learn from them, and then upgrade with a particular question. So it may depend on what pattern matches you have. Whether, like me with my 67, I had none. Actually, I should have known that upgrading wouldn't get me any more. If I don't match a 67, I probably won't match a 111 either. So if that's your problem, it may not help you. But I wouldn't ever say don't upgrade. I would say decide what it is you want to learn by upgrading. And if you have certain matches, you may want to see if they, particularly if you have other surnames to your own, you may want to see whether they still match you at 67. If they don't, that may be an indicator that they're not of interest to you. So you can eliminate things from your inquiry. So there's all kinds of reasons why it can be useful. I wouldn't say yes or no without looking at your results.
And of course, if you have done the basic YDNA37 test, you should also join the relevant surname project and also the relevant haplogroup projects as well. And there may also be geographic projects for the particular area that your surname came from, and it would be useful to join those particular projects as well. A question here from this lady.
I haven't got one of my male relatives to do the Y test yet. Which one do you recommend doing as a start? Do you do the lowest one, or would you pick one of the higher ones?
Well, I would generally say start with either 37 or 67. And a lot depends on how deep your pockets are, what you want to know, how likely you are to want to continue to upgrade in the future. It is slightly more expensive to do a 37 and then upgrade. In other words, you get a discount if you do the 67 all at once. So it's a cost question, really. You get more information from a 67, but actually I tend to say to most people, begin with 37, see if it tells you what you want, and then decide later if you want to continue. And there may be slightly higher expense by having done it in 2 stages, but that's actually less expensive than doing 67 all at once and realizing that it didn't help you. Yeah, 37.
Great. Okay. Well, thank you very much for your questions. And thank you very much, John Cleary, for a wonderful presentation.
Thank you very much.